Remember when we had that 23 or 26 times 25 times 24 times 23 times 22 that we were starting to find when we looked at the possible combinations for a 5-character password? Well, where you couldn't repeat any of the characters. Well, we have something like that going on. We call it factorial when it goes all the way down to 1. So it's just decreasing like this all the way down to 1. We call it n factorial, and there it's written, n factorial. It's the product of all positive integers less than or equal to n, where n is some whole number. So like 1, 2, 3, 4, 5, etc. You can even do 0 factorial if you want to. But this would be part of 26 factorial. That's what this is. So this n factorial, this would be part of 26 factorial. But it would continue on, like I said, down until you get to 1. So 0 factorial is 0 factorial is defined to be 1. And here's another example. 5 factorial is 5 times 4, just take away 1 every time, times 3 times 2 times 1. And so if we want to do 8 factorial, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we can multiply all of those together by, say, 56 times the next pair is 30 times 12 times 2. And we can keep multiplying. 56 times 30 times 12 times 2, and we get 4,320 as our result. And before I forget to mention, factorials are a tool count the number of outcomes. So we can do other things with factorials, and we'll see them in fractions quite frequently. 3 factorial over 0 factorial, we just have to do 3 times 2 times 1 over 0 factorial, remember, is defined to be 1. And when I multiply all that out, I get 6. Okay, here's another neat way to work with factorials. And that is to think about the numerator as 89 times 88 times 87 factorial, all over 87 factorial. Do you see why I stopped at 87 and didn't write all the rest? Yeah. So now 87 factorial in the numerator and in the denominator are the exact same thing. It's like 2 over 2. They reduce, and I'm left with 89 times 88. And I could simply find my result, which is 7,832. Okay, we can also look at 7 factorial and then put it over 5 minus 1 factorial. So this would be, I'm looking at that denominator first because I'd love to be able to reduce like we did up here. So I'm thinking 5 minus 1, that's 4. So I'm going to rewrite it as 4 factorial. And then I want to write the numerator as 7 times 6 times 5 times 4 factorial. And I'm stopping purposely because the 4 factorial in the numerator matches the 4 factorial in the denominator, and it'll reduce with it to 1, and then I can just do 7 times 6 times 5. 6 times 5 is 30, and 7 times 3 is 21, so I think I get 210. If we're not sure, we've got the calculator. 7 times 6 times 5, 210. All right, one more for us to try out. And it has a 5 factorial in the numerator. I don't know what I'm going to do with it yet, so I'm just going to leave it. And then the 3 factorial I know is 3 times 2 times 1, and the 4 factorial, wait, it's 4 minus 2. So I think I might want to change my mind. and leave the 3 factorial, because 4 minus 2 is 2, so we're going to be multiplying this by 2 times 1, which is just a 2. And now I think I'm ready to write out my numerator. So I want 5 times 4 times 3 factorial, stop there, all over 3 factorial times 2. My 3 factorials reduce to 1. And then I have 5 times 4 over 2. My 2 goes into the 4 2 times, and then I multiply 5 times 2 is 10.